Solutions to quiz 1 from Math 251. We're asked to find the slope of the secant line of x given two x values. All right, the slope of the secant line is the change in y over the change in x. This is also called the average rate of change in Math 111. So we have the two x's. All we got to do is figure out the two y's. You can figure out the first y by putting 2 into this equation. So we got negative, so maybe I'll write y1 is f of 2, which is negative 2 squared plus 3 times 2 plus 1, which is negative 4 plus 6 plus 1, which is 3. And similarly, y2 would be f of 3, which is negative 3 squared plus 3 times 3 plus 1, which is negative 9 plus 9 plus 1, which is 1. Be a little bit careful. This is negative 2 squared, not negative 2 squared. So that'd be easy to make a mistake in there. But at any rate, if you figure out these two y values, the problem's pretty easy. You're just plugging in. You get y2 minus y1 over x2 minus x1, which is negative 2 over 1, or negative 2. In part B and C pretty much just repeats that same thing. Let's see. All right, so let's see here. It's the same idea, except now we need a new y2. So y2 here is f of 2.1, which is negative 2.1 squared plus 3 times 2.1 plus 1, which is equal to 2.89, I think, if you throw that in a calculator. So we can figure out the slope here. See, y2 is what changed. It's now 2.89 minus y1 is the same. x2 changed to 2.1 minus x1 is the same. So if you do the math here, what do we got? Negative 1.1 divided by 0.1. Oh, sorry, negative 0.11 divided by 0.1, and that's equal to negative 1.1. And then finally, down here, y2 is f of 2.01 is negative 2.01 squared plus 3 times 2.01 plus 1. And if you calculate that out, you get 2.9899. We can now figure out the slope is 2.9899 minus 3 over 2.01 minus 2, which is 0.0101 divided by negative divided by 0.01, which is negative 1.01. All right, using your answers above, estimate the slope of the tangent line to f at x equals 2. So the idea with the tangent line is it's kind of like the secant line. It's the limit of the secant lines. So the limit as the second x value gets really close to the first x. So if you kind of look at the pattern we have going on here, negative 2 down to negative 1.1, down to negative 1.01, it appears that the slope of the tangent line to f at x equals 2 is negative 1. At this point, we don't know how to prove this. Later on, we'll be able to prove it. For now, we can kind of just guess. I don't know. That's what it looks like it's getting close to. Good enough. All right, the equation of the tangent line. The equation of the tangent line, you can use point slope form. So we know the slope. We know m equals negative 1 from part D. So all we need is a point. See, we know the x value, x equals 2, maybe x1 equals 2. So all we need is another point, y1, which we calculated earlier when x1 equals 2, y1 equals 3. So if you plug in these three values over here, you get y minus 3 equals negative 1 times x minus 2. So you get y equals negative x. That's that plus 2 plus 3 is plus 5. And this right here is the equation of the tangent line. Suppose that f of x is a function modeling the height of a ball in meters at time x in seconds. Interpret your answer to part A. Okay, my answer to part A was the slope of the secant line from 2 to 3 is -2. So what I would say is the average speed of the ball from 2 to 3 seconds is -2 meters per second. In other words, the ball is going down at a speed of 2. Negative means it's on the way down. So ball is going down at 2 meters per second. All right, under these same assumptions, interpret your answer to part D. My answer to part D was that the slope of the tangent line is -1. So what I would say there is the instantaneous speed of the ball, blah, 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 of the ball at time 2 is -1 meters per second. So the key here is that the interpretation of the slope of the tangent line is the instantaneous speed, and the interpretation of the slope of the secant line is the average speed. And I guess that's the end of this quiz.